All right, so we're going to do our notes today. Cube root operations part 2, divide. The nice thing about today's is the rules are the same as for square roots, but again, we're taking out triples. That's the only difference. So this should help you if you have to correct your square root test, because it's kind of the same similar rules, so it'll help you practice. So we never, ever, ever leave a radical in the denominator. So today we're going to look at dividing radicals and rationalizing the denominator with cubes. So the steps. The very first thing you want to do is look at reducing the numbers outside the radical and reducing the numbers inside the radicals. Okay? If you do that, it'll make your problem so much easier. So I have 2 over 6. They're both divisible by 2. 2 goes into 2 once. 2 goes into 6 3 times. So I'm just reducing that fraction. You can do it in your calculator too. Type in 2 divided by 6, enter, and it'll simplify it. If it gives you a decimal, hit math, frac, for fraction, enter. 75, the cubed root of 75 over the cubed root of 5. So you can reduce that. They're both divisible by 5. Good. Cubed root of 15 over cubed root of 1. Well, we know what the cubed root of 1 is, right? 1. So it cancels out. So on the bottom, we just have 3 times 1. And then on the top, we have the cubed root of 15. I would always look at it again to see if you can simplify it. If you followed the rule and reduced first, it's usually okay, but I would always just kind of check with your little upside down birthday cake, keep dividing that repeated division, and make sure that you don't have 3 of anything left that you can take out. And then you shouldn't have any radical signs in the denominator ever. Okay, because that's the goal. You want to get rid of those. So the very first thing you want to do, you always want to look at the outside numbers. That's it. We rationalized the denominator. We reduced it. We rationalized the denominator. We're good to go. You always want to do that reduce first. It'll make your numbers easier to deal with. Your numbers won't get big and crazy. So I can reduce 70 and 10. They're both outside numbers. They're both divisible by 10. So I have 7 over 1. And make a little change here. This is supposed to be a 3 for cubed root. She just accidentally hit 4 when she was typing. So now I have 1 times the cubed root of 6. So I reduced, but I still have a radical in the denominator. I'm not allowed to have that. I have to clear the radical from the denominator. So I want to multiply both the top and the bottom by a radical that will complete the cubic triple. Because if it was a square root, we'd just multiply it by square root of 6. But it's not a square root. It's a cubed root. So I have 1 6. And if I want a triple, I need to have 2 more 6's. So exactly. So I'm going to multiply it by the cubed root of 36. So if I multiply it by the cubed root of 36, I have my 3 6's. I had 1, and now I have 2 more. I have to multiply the top by the cubed root of 36 also. So on the bottom, I get just 6. It simplifies to 6 because I have those 3 6's. The 1 I don't need, it cancels. At the top, I have 7 cubed roots of 36. Now I should always check and see if I can take anything out. So my repeated division, 36 divided by 3 is 12. 12 divided by 2 is 6. 6 divided by 2 is 3. I can see those two 6's there, the 3 and 2 and the 2 and 3, but I don't have 3 of anything. So I'm done. Okay, so you always want to look again. I think the one that hides under there the most that you can reduce is the cubed root of 8. If you ever have a number under here that's divisible by 8, then that tells you you have a 2 hiding in there, right? Because 2 cubed is 8. So that's the littlest one that I think hides in there, and then you have to always reduce. So you kind of get the idea. We needed 2 more 6's to make it a triple. Now sometimes you have to kind of look at the problem though. Like number 3, I can't reduce 6 and over 25. Even though they're both inside numbers, they're not divisible by anything in common. But if I think about it, 25 is actually 5 squared. So I really already have 5 times 5. So I want to add another cubed root of 5. And so now I'll have 3 5's. I have to multiply the top by the cubed root of 5. And so if I multiplied it, I mean, what I'd really get is the cubed root of 125, right? And that's just 5. You with me? So sometimes you can look at it, you might already have 2. Like if I had a 16 under here, I would have 4 squared. I might have, 49 under there, which might be, I already have 2 7's. I just need 1 more. So sometimes you need 2 more, like when I needed 36, but sometimes if you look at it and it's something squared, you only need 1. So if I multiply the top, remember I multiply inside numbers with inside numbers, so on the top I get the cubed root of 30. And so then I should look. If I simplify 30, well, it's not divisible by 8, so that's not hiding in there. Let's see, I'll pick a 3. 30 divided by 3 is 10. 10 divided by 2 is 5. I don't have any group of 3 that I can take out. So always just kind of double check. Make sure you don't have anything you could simplify. So I don't have any radicals in the bottom. It's good to go. What do we multiply by 25 to get a perfect cube? It would be that 5. So number 4, y'all tell me, what would you do first? Yeah, I would always reduce first. Use that, look at that rule first. So 8 divided by 2 is 4. 2 divided by 2 is 1. Then what would you do? Good. Reduce 15 and 10. Cubed root of 3. 15 divided by 5 is 3. 10 divided by 5 is 2. Now what would you do? I have to multiply because I want to rationalize the denominator. But what would you multiply by? The 1's gone. I have a 2. What do I need to multiply by to make it triple? I need 2 more 2's. This is 2 to the 1. I need 2 more 2's to make a triple, so this is a 4. Good. So up here, cubed root of 4. On the bottom, it's just going to be 2. And on the top, it's going to be 4 cubed roots of 12. Okay, because outside numbers multiply with outside numbers, and this coefficient's just 1, and then inside numbers multiply with inside numbers. And then I should always just kind of look. So I have a 12 divided by 2 is 6, divided by 2 is 3. I don't have anything that I can simplify on the top. What about the outside numbers, though? Can I simplify those? Yes. So they're both divisible by 2. So this would become, my answer would be 2 cubed roots of 12. Yeah, over 1, or you don't even really need the 1. You only need the 1 like if you're just as a placeholder if there's something in a denominator. But you don't even have to write the over 1. What do you think? Yeah, pretty easy? Awesome. I was hoping you'd say that.